Mr. Miller here again with another video, wearing the same thing and I'm wearing one of those other videos. It's almost like I recorded them back to back. In an unrelated topic, I need a sip. All right, my friend said, what rhymes with orange? I said, no, it doesn't. You know, I gotta grab a better pen. Here we go. Okay, I think I can talk right. I don't know what to name these videos because we're gonna do a lot today. So one, we're gonna convert from standard form to vertex form, and then we're gonna graph vertex form, and we're gonna graph standard form. So you know, it's interesting, but let's just get after it. Why this is part two is because that's an odd number. So we're gonna run into some decimals, okay? It's a little, you know, not as clean as when the middle term is even, and you know, a is equal to 1. But let's just get after it anyway. We know if we're gonna convert into that form, we get to complete the square. I mean, that's the beauty of vertex form. It has that lovely binomial squared. So let's get after it. So here we go. We're gonna make a square. Put our dimensions. We're going to take this -3. Oh man. Here we go. Minus 1.5 minus 1.5x. I mean, you may be saying, like, when we solve, a lot of times we multiply everything by 4 to make that number even. But we can't do that if our goal is vertex form. Because in vertex form, that coefficient in front of x is 1. So this has to be x squared. Can't be 4x squared. All right, so let's just deal with it, right? Let's just deal with it. We got -1.5 and -1.5. The other thing to realize is we just got to embrace the fact that we know the vertex is not at an integer. When a is 1, if that middle term is odd, the vertex is not at an integer. If the middle term is even, it is at an integer. So the fact that we're getting decimal points just has to be something we roll with. Let's keep it going. Let's keep it going. So here we go. We're gonna fill in our complete the square area. That's 2.25, which is -1.5 times -1.5. Well, we have 5 up here, and we want 2.25. So that means we're going to need to subtract, not 3, but 2. That would get us to 3, right? And then 0.75 more will get us to 2.25. Whatever we do to one side of the equation, we got to do to the other. All right. Hey, the numbers are looking a little messier, but it's all going to work out. So let's just keep going with it. That means y minus 2.75 is equal to x squared minus 3x minus 2.75. All right, let's stick with me, okay? Stay with me. Let's keep going. That means that y minus 2.75 has to be the same as x minus 1.5 squared. Hey, it's still so beautiful. It still works out. It still works out. Now I got to add 2.75 to both sides, right? So this side is going to go away. So it's just y is equal to, and I'm going to add it over there. So x minus 1.5 squared plus 2.75. All right. Now we got to graph it, okay? Like, hence the challenge. And what do I name the video? We're doing so much. We're doing so much. So let's do kind of a rough graph. You got to think in vertex form, when a is 1, right, or when a is positive, it's a minimum value, and the smallest number that y can ever be is 2.75, because that green rectangle can never be negative. As small as it could ever be is 0. And when it is 0, y is 2.75. So it's going to be up here. Let's just say 2.75. Then you want to ask yourself, what value of x makes that 0? And that is 1.5. right? Because 1.5 minus 1.5 squared is equal to 0. So we go over 1.5 and point it up, and it should have the same shape as the parent function. Over 1 up 1, over 1 up 3, over 1 up 5, yada, yada, yada. You can also get it directly from the form. This is exactly vertex form, right? It's a subtraction and then an addition. And so the values of h and k will always be the vertex. There's a lot of ways to think of these problems, right? A lot of ways to think about them. All right, well, I want to give you one to try, and I may tweak it just a little bit. Let's see. You're like, oh no, he didn't. He didn't make that negative, did he? Oh my God. Hey, give it a shot. Hit pause. Unpause. All right, well, we want to start the same way we've been starting all of these, which is if we're going to graph this, or if we're going to convert it to vertex form, we need to make squares. But that's not a perfect square. You can't make a square on a negative x squared. Right? You can't multiply two numbers and be negative if the numbers are the same. So you got to do initially. All right. Well, the camera just fell, but now it's back up. So let's finish the problem. So the first thing we want to do on this one is multiply everything by -1. Every term gets multiplied by -1. Because what that'll do is make our x squared positive, and then we'll be in really good shape. So now it's going to be -y is equal to x squared. Oh, I don't want to write it there. Let's write it here. So it'll be -y is equal to x squared minus 5x plus 3. Okay, so now we can complete the square, because now that's a positive x squared. So I'm going to go x times x. We're at -5. We're accepting the fact that we know the vertex is not at an integer because of the odd middle term. So -2.5x times -2.5x. That means this is -2.5 minus 2.5. And we get to complete the square again and again and again. But this time it is 6.25. Hey, it's still a beautiful number. It's still, and 0.25, that's a half times a half, right? So when you see that 0.25, you should be like, yeah, that's nice. That's nice. That feels comfortable. So we need -3 to be 6.25. Not a problem. If we add 3, we'll get to 0. And then I need 6.25 more. So I'm going to go 9.25. Let's add it to both sides, okay? So plus 9.25. Let's keep it going. I feel like we're doing really good. So -y plus 9.25 is equal to x squared minus 5x plus 6.25. Here we've got our square. So let's rewrite this area as x minus 2.5 squared. Beautiful. Let's just not skip any steps here. So rewrite that. Okay, so I just rewrote the area as the dimensions. Let's subtract 9.25 from both sides. And now we have one last move, and because we initially multiplied by -1, we actually got to multiply by -1 again, because ultimately I don't want to know what the opposite of y is. I want to know what y is. So we need one last multiplication by -1. All three terms. Y is equal to -1 x minus 2.5 squared plus 9.25. Remember, this whole square, that's one term here, so I'm just putting the -1 out there. I'm not distributing it, because I can't distribute into into the exponent, all right? So let's graph. We've made it to the graphing stage. It's the same shape as the parent function because the a value is -1, except it points down. So it should be over 1, down 1, over 1, down 3, over 1, down 5, over 1, down 7, over 1, down 9, over 1, down 11, down 13, down 15, down 17, down 19, down 21, down 23. Michael Jordan's number. Okay. So let's see, we got to ask ourselves, when is the squared term going to be 0? That question is not affected by that -1 out there. So it's going to be 0 when x is equal to 2.5. Just 2.5 minus 2.5 is 0. So I know the axis of symmetry is over here at 2.5. Yeah, right? You know, you get those questions sometimes. So x is equal to 2.5 is the equation of the axis of symmetry. Huh. Wow, Mr. Miller. I was not expecting that nice piece of knowledge. Thank you for that. All right, so now we got to go up 9.25. So let's just assume that that's here, 9.25. So there's our vertex. Our vertex point is at 2.5, 9.25. And it should point down. And as I said, it's just the parent function flipped upside down. All right. Well, we made it through that one. Hit you with a little curve there at the end. Hopefully you enjoyed learning this topic. I hope your day treats you with kindness and respect. It is a privilege to have done this. All right. Take care.